At Arcam Technologies, our mission is to accelerate the clean energy transition for all using 3D concrete printing. Floating photovoltaics, or FPV, uses pontoons on bodies of water to create solar projects without taking up valuable land area. FPV plants can increase power production by 2 to 20% and provide co-benefits to reservoirs by reducing evaporation. As revealed in our customer discovery interviews, ensuring safe and cost-effective anchoring of arrays is a critical challenge in FPV projects. Each project requires time-intensive one-off engineering to design anchors suitable for the site's soil, and any mooring failure can lead to catastrophic system failure and injury. Today's FPV plants are anchored by simple concrete blocks weighing 2 to 5 tons each. A typical plant uses 10 to 30 anchors per megawatt. Concrete blocks are over-designed and inefficient due to their limited horizontal capacity. Challenges with conventional anchors lead to increased project costs, slower development, and difficult logistics. Arcam's innovation is a turnkey solution for designing and manufacturing efficient anchors using 3D concrete printing. Using our proprietary anchor design algorithms, it will be possible to design and manufacture site-optimized anchors for an entire FPV plant, slashing project engineering time and costs. The anchor designs are then sent to a 3D concrete printing system at the FPV site or nearby. The printer will fabricate anchor shells with skirts on the bottom. The hollow shell design allows for the anchors to be floated out for installation and then sunk by filling it with low-cost ballast. As the anchor sinks to the bottom, the skirt locks into the soil, providing additional holding capacity. The result is a material-efficient alternative to the conventional block. During the set contest, we made critical strides in design, printing, and preparations for a pilot anchor demonstration. First, we refined our anchor design to improve printability and developed the first version of our parametric design algorithm. The algorithm was built using Grasshopper with Rhino 7 CAD software. A user-friendly visual interface allows the user to easily adjust the anchor geometry and add shear keys. Along with outputting a design, the program also calculates the anchor weight, produces a print path, and estimates print time. We demonstrated the functionality of this software by using it to design anchor prototypes and print them on a desktop 3D printer. This process revealed printing risks and informed further design improvements. We also de-risked critical aspects of the 3D concrete printing process with our partners. These activities included developing a baseline printing concrete mixture and performing trials with both robotic arms and gantry printing systems. The set contest has been instrumental in accelerating our innovation. In addition to our technical progress, we have completed 11 customer discovery interviews with FPV project developers, technology providers, and engineering consultants to find our beachhead market and to understand the value propositions of our anchor versus the status quo. We laid the groundwork for a pilot demonstration by partnering with FSEC and NEL-HA and the American-Made Network, who helped us identify several sites for anchor testing in inland reservoirs and ocean environments. We also met with Matthew Ingram, a geomechanics expert who helped us plan experiments at Sandia National Lab to validate our anchor performance models. FPV is rapidly scaling, with over 10 gigawatts predicted by 2025. A recent NREL study estimated that FPV has conservatively over 2,000 gigawatts of potential within U.S. reservoirs alone. Emerging technologies can bring FPV offshore to further expand capacity. The Gulf of Mexico alone has 86,000 gigawatts of gross FPV potential, 46 times that of offshore wind. Our initial beachhead market for FPV anchors is reservoirs with impermeable liners in California and the southeast U.S. These initial installations will help reduce costs to enable competitiveness in other reservoirs. We then aim to scale the 3D concrete printing technology to the global offshore FPV market. Arcam Technologies is a dynamic startup led by founders with over 30 years combined experience in renewable energy and concrete at NREL and UCLA. We have a world-class mobile 3D concrete printer and R&D facility at the Port of Los Angeles. We are growing our in-house engineering department. During the contest, we assessed our team and filled key gaps in order to ensure success. We built key relationships with project developers and engineering consultants experienced in FPV, along with 3D printing partners and geotechnical engineers needed to complete a full-scale prototype demonstration. The opportunity in floating PV is tremendous. With continued program support, we will commercialize an unparalleled American-made innovation that facilitates FPV development around the world and brings affordable clean energy to all.